Next is transformer ratio. What is transformer ratio? That is, for an ideal transformer, means that is a flux linking with the coil, the primary to the secondary. There is no leakage of due to the reactance or the resistance. Whatever is there, it is, the losses will not be taking place. Therefore, whatever the voltage is there, that will be induced as a EMF E1. That is V1 equal to E1. That is said to be the ideal transformer. Ideal. Here also, what is that? The EMF induced in the secondary coil is equal to that of the, what we can take it as? We can take it as a output voltage. What is the meaning of that one is, that is, the whatever the EMF is induced here, that goes as the output. In between, there is no leakage due in the conductor. Conductor will have some resistance. If it has some resistance, what happens? There will be some drop. Drop means what happens? There will be some losses taking place in that conductor. Therefore, in case of ideal transformer, we are telling that that kind of losses are not taking place. Therefore, whatever the voltage you are applying, that will be induced in the primary, that is said to be V1 equal to E1. And whatever the EMF is induced in secondary, that will be going out as the output to the secondary load, that is said to be V2 is equal to E2. But this is not practically possible. Usually in a practical transformer, that some losses will be taking place, and these two will not be equal. Therefore, what happens? We are considering as an ideal transformer. In ideal transformer, V1 equal to E1 and V2 equal to E2. Therefore, what is that in this case? It just transfers energy from one circuit to the other. That is, we are doing to either the input voltage is, that is primary, that has to be either increased or decreased. But what happens? The power flow means what is that? Power from the input to the secondary should be of same. Understood? Therefore, what happens? V1 into I1, that is a power in the primary, and V2 I2 is said to be the power in the secondary. Actually, the power equation should be same. That is, power equation of the primary should be equal to the power equation of the secondary. This is for all transformers. Therefore, V1 I1 is equal to V2 I2. When you are considering these equations, we can take the ratio, that is V1 by V2 is equal to what? We can take it as I1 by I2. Since V1 is equal to what? It is equal to E1, and V2 is equal to E2. This is said to be E2. This ratio is said to be the transformation ratio. Therefore, V1 by V2 is equal to I2 by I1 is equal to E1 by E2 is equal to K. K is said to be the transformation ratio. Therefore, what is the EMF induced in the primary? Already we derived. EMF induced in the primary is nothing but E1 is equal to what? 4.44 F phi m N1. What is the secondary induced EMF? 4.44 F phi m N2. Therefore, the common terms get cancelled. Therefore, what you will be getting? You will be getting E2 by E1 is equal to N2 by N1. Therefore, this is also equal to K. Therefore, overall we can say the transformation ratio is nothing but V1 by V2 is equal to I2 by I1. See here, V1, that is equal to I2 by I1, and E1 by E2 is equal to K, N2 by N1 also is equal to K. This is said to be the transformation ratio of the transformer. Based on this K only, we can say whether it is a step up or step down. Okay, that we can see in detail in the next. Now we can go for the problems. Problems means what? We are going to see about the problems in the transformers. Now consider, based on this we are going to find it out. Consider a 25 kVA transformer.